today's lecture we are going to discuss what is integer modulo n group. Okay, so whether my screen is visible to everyone?
Yes, sir.
Yes, it is.
Okay, so this is what the some example I have given you as a homework in the last to last lecture, whether this is group, whether the second one is group, whether third one is group, or whether fourth one is group. Okay, I hope you have a good idea about this. Okay, now write down integer modulo n group, or we defined as a Zn. Okay, so write down it is a finite group. It is a finite group. Integer modulo n, and it is denoted by Zn. Okay, so what is that? What is that group? Okay, so we define, first I just discussed that the set Zn contains elements starting from 0, 1, 2, dot 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 up to n minus 1. Whatever we have, that n is nothing but integer. So n minus 1 element it has. How many total elements we have in that group then?
N
Yes.
minus 1?
No, 0 is also there. No.
No, I thought you
Total
were saying, okay,
total elements. What is the cardinality of Zn?
okay.
It is n, where n is greater than equal to 1. Okay. So this is nothing but what I have my Zn. Now the meaning of that is what? The meaning of that is what? Suppose let I have suppose Z5. So how many elements we have in Z5? It is 0, 1, 2, 3, and 4. That many elements. Okay. What happened? Whether, my question is whether my 8 belongs to Z5. The question is that then what you need to find? You need to find out 8 is congruent to which number, mod n or mod 5. Tell me what is that number? And that number should be less than 5. So what is that number? 4. Here, that number is nothing but the remainder. Okay. So here, if you divide by 5 to 8, so 8 divided by 5, 5 ones are 5. What remainder remains? 3. So you can write down 8 is congruent to 3 mod 5. Are you getting? Are you getting? Tell me 125 congruent to which mod 5?
0.
Yes, it is 0. So whenever 125 number comes, instead of 125, I just write down 0. So whether 125 belongs to Z5, the answer is yes, because it is a modulo group. It is a modulo group. We already discussed what is meant by that. The meaning of that is nothing but what? 8 minus 3 is divisible by 5. That is the meaning. Okay, so that group, when I say sorry, it's not right now, we don't know whether it is group or not, but the set, that set Z5 0 1 2 contains a 5 elements. It is and contains lots of elements, infinitely many elements, but still it is finite because cardinality is finite. Why? Because of this operation, integer modulo n. Everyone understand that group? Yes or no?
Yes, sir.
Okay, now we need to check whether this set is a group or not. I just talked about group. So let's first discuss whether it is group or not, under multiplication or under addition. So write down the question 1. Check. Now instead of taking Zn, I just take any value of n. Just tell me which value. Can I take Z6? Is group with addition. Simple. First, we will discuss addition. So we need to check, that is Z6 plus each group. This is what I have a question. Okay. So tell me how we can find out finite group, whether it is group or not. We made a, what we are doing. Yes. Tell me. What?
First, we need to take set of Z6.
Okay. So first we write down for Z6. Okay. So we start here. Z6. Tell me how many elements we have in Z6? 0, 1,
Up
2,
to 5.
3, 4, 5. Okay. Now
We need to check whether it is group or not.
how one can check?
Like we need to take any number and belongs to. We need to check whether does it belong to Z6.
Okay. How you are going to check that one? That is what I have my question.
Like we can take, for example, that can I take any number?
Okay.
That 9, does 9 belong to Z6, like that?
Does 9 belongs to Z6? Okay. How you can check all the numbers? What is the definition? Well, we need to check whether these 6 properties are satisfied or not. Yes or no? That 4 properties, not 6 properties. That 4 properties. Yes or no?
Yes.
So I just try to make that table so you will understand. In the last lecture we discussed no table, one table. Yes or no?
Yes, sir.
What is the table?
Yes.
How we form that table?
So you have to write the elements on top as well as like vertically, and then like multiply them, or
We need to
whatever the
make a table. Firstly, we
whatever the
need to make a
function.
table. So first I just try to draw a table, a good table. So we need to require 7 by 7 table. Okay, now I need to increase that table. Why it's not happening? Okay, I'm not, this is not working, so I will make my table. Okay, just forget about that. So we will make a table like that. Okay, so we have plus sign here. Okay, so we have this operation. Then we just make a table like that. Here we have 0 element. Here we have 1 element. Here we have 2. Here 3. Here 4. And here 5. We also write down in a row format 1, 2, 3, 4, and 5. Whenever we have a finite group, you need to draw that table. Okay. Now tell me, what is first element? So 0 plus 0, what you are getting?
0.
0. Here 1, 2,
It
3,
will be the same up to
4,
5.
5. Okay, here also you will get same thing. 1, 2, 3, 4, 5. Next, tell me now. 1 plus 1.
2,
1 plus 3.
4,
Oh, sorry. 1 plus 2, it is 3. It is 4. What about this?
5,
5. What about this?
6.
But 6 whether belongs to Z6.
No.
So we need to convert. So 6 is congruent to which number mod n? Mod what? Mod 6.
1.
1. If I write down 1, the meaning of this 6 minus 1 divides 6. But 6 minus 1, 5. 5 does not divide 6. What it
0,
is?
sir.
It
0.
is
0.
0. It is 0. So it is 0. Everyone understand how 0 comes here?
Means if it doesn't belong to that group,
No,
then
no,
we
no,
need to
no,
write
no,
0.
no, not like that. It is the meaning of whatever you are getting addition. This addition to congruent to which number to mod n? Okay, so
Okay.
let's go further. You will understand what comes here.
3,
3 here,
4,
here.
5.
Okay, here.
Now 6.
6 is congruent to
0.
0. 0. Yes. What
Okay.
is here?
7.
7 is congruent to which mod? 6?
1.
1. Everyone
One.
understand that? Everyone understand that?
Yes, sir.
Okay. Now tell me what is next. 4. Am I correct? Here 5.
Yes.
Here
0.
0.
0.
1.
Here 1.
2.
8. 8 is 6. It's 2. 2 congruent.
2.
Yes. What is here?
5.
5. 6. Sorry, 0.
0.
0.
1.
1.
2.
2.
3.
3.
3. What is next?
5. 0. 1, 2, 3.
5 plus 1. Here 6. 8. 0. Here 1.
0.
Here 2. Here 3. And here 4.
4.
Correct? Everyone understand that table now? Congruent modulo n.
Sir, means whatever is not congruent, we have to write there 0 because it comes as a remainder.
Whatever it is not congruent here.
No, means
What is
like
5
6
plus
is
5? What is
I mean
5 plus 5?
10.
So whether I write 0 here? No.
Okay.
What it is simply whatever you are getting addition, suppose 10. So whether 10 is congruent to which number mod n?
0.
You need to find how it is right now. It is 0. If I have 16, then 16 is congruent to which mod? 6. Tell me what is that number. So you need to divide 6 divided by 16. 16 2s are 6 2s are 12. So
4.
4. You are getting 4 here.
4.
And when I talked about 10 is congruent to which mod? 6. Tell me what it is. What it is?
4.
It is
4.
4. Everyone understand that? So we are interested
Yes.
in that number because the definition of congruent is like this. And we define this is Z6 is a congruent modulo n or integer modulo n. It is integer modulo n is nothing but what? Whatever you will get, these all are the remainder. You can divide 6 to any number, you will get this only remainder. Yes or no? Any number, you can take any number, divide by 6. Either you will get 0 as a remainder or 1 or 2 or 3 or 4 or 5. Yes or no? Again, if you get another number, again 0, 1, 2, 3, 4, 5. So this is what we form a group. Now we need to check what is identity element, what is additive and everything here. Okay. So yes, everyone understand that now?
Yes.
Anyone, any doubts here? Any doubts, anyone?
No,
No,
sir.
sir.
Okay. Now first property. What is our first property of group? Closed one. Tell me whether it is closed or not. How to check whether it is closed or not? How to check whether it is closed or not? Yes, anyone? I think we take some same example in your last lecture, no? Little bit having some 1 I minus I. So how we discuss whether it is closed or not? We need to check all the elements, whatever the answer you are getting, you need to check all these elements and these elements, whether that all elements belongs to Z6.
Yes, sir.
Yes, you can check it out. No, so whatever element you multiply, you do the addition in between them. Whatever your result you are getting, that result also belongs to Z6. That is the meaning now. So for all A and B belongs to Z6, we have A plus B also belongs to Z6. Yes or no? So close property is satisfied. What is associativity? So we know plus is associative on Z for whole integers. Whole integers means what? -1, -2. The plus is associative. We already shown that Z plus is a group. Okay. So this implies plus is associative on Z6 also. Okay, because it is a subset of.
Sir,
Yes.
can you tell for a closed? I didn't understand that.
Very simple. No, take any element. What is mean by closed? Tell me.
Means the condition for all AB belongs to Z.
Then
Okay, these all elements belong to Z6, correct?
so what are we have? How many elements? 6 elements.
Yes.
So that 6 elements belongs. You can take any 2 element and do the addition. Addition is nothing but my binary.
Okay.
So that is what I did here, no, in that table.
Yes.
And what is my answer? Whether I get any number which is out of that group.
No.
That's it. So it is closed. So I can
Okay.
take any element from that set. I do the addition which among them. Okay. And whatever I am getting, these are my all possibilities.
Okay.
And that possibilities also belongs to Z6. So
Okay.
therefore it is closed.
Okay.
Okay. Now
Yes.
the Z, you understand associativity? Associativity, we know that Z plus is a group. Yes or no? Z plus is a group. We already discussed that. We already solved this one. Okay. What is identity in Z plus? What is identity?
0.
0. And what is inverse? Inverse of A?
minus A.
Minus A, exactly. So Z plus is a group. So there plus is associative on Z. Plus is associative on Z. We took a subset of Z6. Whether this is subset, yes or no? What is mean by subset? What is mean by subset? Whether these all elements belongs to Z, 0, 1, 2, 3, 4, 5, 6.
Yes.
And it
Yes,
is a
sir.
small set. So it is obviously subset. So if on a bigger set, the Z is associative or Z satisfy associative property, it means on a smaller set also it's satisfied. Yes or no? Because it is usual addition only. Whatever that addition I'm getting number, it is usual. Got it? It is inherent property. Okay. Now tell me, what is identity element? What is identity? What do you think? What is identity here? What is the value of E? Yes? 0. 0 is the correct one. How it is 0? Because you can see if you add C, because A plus 0 is equal to 0 for all, or you can also write down another way also, and 0 plus A is equal to A for all A belongs to Z6. See now, if I take any number 0 plus 0, 1, 0 plus 0, 0, 1 plus 0, I'm getting same number, 2 plus 0, I'm getting same number, 3 plus 0, I'm getting same number, 4 plus 0, I'm getting same number, 5 plus 0, I'm getting same number. That is what the definition of identity.
Mean
Yes
this
or no?
identity satisfies.
Yeah, identity is there. 0 is the identity. You can say that 0 is the identity of that group. Identity is not satisfying. 0 is the identity of that group. Okay, identity element. Got it? Now the inverse.
Yes.
Now we need to find the inverse of all elements. What is the inverse of 0? We have, I just write down A here, or we just made a table. Here we need to always make a table. Here you have A, here you have A inverse. So A is equal to 0. Write down the all elements. And you just tell me what are the inverse of these elements. So we require table also. We have 0, 1, 2, 3, 4, 5. Tell me what is the inverse of 0?
0.
0
0. Correct. What is the inverse of 1?
minus 1
Minus 1 is there.
No.
Then yes, minus 1 is there. So whether it has an inverse.
No.
Okay. Someone is saying whether it has an inverse or not. Anyone? Look at that table. That why we draw that table.
No, sir. -1 is not there.
So only -1 is the possibility to have an inverse. What is mean by inverse? Tell me the definition of inverse. Yes, tell me the definition.
So it should be equal to identity element, this sum.
It should, it should be. Tell me, what should I write down? Suppose my identity is
Yes,
equal to 0. So 1 plus something, I will get 0.
5.
Yes, it is 5. Because 1 plus 5, what is 1 plus 5?
0.
0, and 0 is
Like
the
6.
identity.
Exactly.
Yeah, so when we have 1 here, we need to check where I'm getting 0. Yes, here I'm getting 0. So 5 is the inverse of 1, or 1 is the inverse of 5. Like that. Now tell me, what is the inverse of 2?
4.
4.
Now you are getting. What is the inverse of 3?
3.
3.
What is the inverse of 4?
2.
2. What is the inverse of 5?
1.
1.
So whether this is a group,
Yes, sir.
write down. It is a group.
Sir, can you tell how 5 came inverse of 1? I actually got disconnected.
What you are talking?
Can you tell how that 5 came as inverse of 1, because I
Tell
was
me, what is the
disconnected.
definition? What is the definition of inverse?
For
You have
inverse,
identity 0, correct? So I need to
yes,
find the inverse of 1. So
yes.
which number should I add here so I will get 0? Tell me. Someone
We
is
should
saying
get
-1. But whether
yes,
-1 belongs to here.
but yeah, -1 is not there.
So -1 we cannot write down. Forget about -1. So is there any other number? So I just add 0. So 1 plus 0, I am getting 1. I want 0. I add 1. So 1 plus 1 is 2. 1 plus 2 is
Yes,
3. 1 plus 3 is 4. 1 plus 4 is 5.
directly
But 1 plus
5.
5, what is 1 plus 5?
It is actually 6, but it doesn't belong in the group 6.
It is not 6, beta. It is 6. Do you understand that table?
No, I'm saying 6 is not there in this
But
number
I'm,
6.
oh. Do you understand that table?
Yes,
Okay. Tell me, if I add here 1 plus 5, what is 1 plus 5?
6,
Why write down here 0?
because it is 6 is not
That
there
plus,
in
okay. What is 3 plus 5? 5 plus 3.
8.
Why write down 5? Oh, 5 plus 3. Why write down here 2?
Mm,
You
because
have to divide it by 6 and the remainder is written there.
That plus operation is an congruent modular n. That is what I am saying. It is not your usual addition 6, 7, 8.
Okay.
It's not like that. Here, see, I just discussed that here only. If I have Z5 0, 1, 2, 3, 4, if 8 belongs to Z5, so what I need to do, I need to
what's the
find out
remainder?
8 is congruent to which mod number? 5. So remainder I need to write down. So these are the congruent moduli n. This sub addition is congruent moduli n.
Okay.
Getting? So
Yes.
it's not a normal addition. It's not a normal addition.
Congruent.
Yeah, it's congruent. So that's why I write down 5 plus 1, 6. But 6 is congruent to which number? 6 is congruent to 0 mod n.
Yes.
Same here. The 5 plus 3, 8. 8 is congruent to which mod? 6. So it is 2.
2.
So now tell me, if I add 5 here, so what I'm getting? 6. But 6 is congruent to 0.
0.
So that's why I write down 0. And what is
Okay.
0? 0 is nothing but my identity element.
Okay.
And this is what I written here.
Okay.
Got it now?
Yes, got it.
So please keep this thing in your mind because this is quite important. We have finite group like that. These all are the inverse identity associating clause. All properties are satisfied. Therefore, Z6. Therefore, you can write down Z6 together with plus is group. Okay. Clean and clear? Yes or no?
Yes, sir.
Okay. Now next Next, can you find out Z6 into dot is group? Instead
So
of
can you
addition,
please-
we have product.
Excuse me, sir.
Yes.
So can you please like slide down the page a bit?
Okay.
Thank you, sir.
Everyone just work on that. Z6 dot is a group or not? What do you think? Whether it is? Whether it is? Here instead of addition, what we have? We have product.
Yes.
So we need to do the product. You need to think in a product way.
So it means we would require the same table, right? Which you.
Yeah, not same table. Instead of addition, we have multiplication now. Only.
Yeah.
That is the difference.
Okay. Yeah.
Okay.
Instead of plus, we would have to use dot then, but the
Yeah.
number. Okay.
Just you need to check whether number comes in the same way or not, whether it is close, associative, inverse, everything is there. So let's check it out. So form a table, everyone. Form with me. So we have multiplication. So here we have what elements we have in Z6? Z6 we have 0, yes.
5. I'm telling.
Last element is 5. You can take any number, Z3, Z5, Z2, Z1, any number. Okay. So here I just take any 6. That's one. So 0, 1, 2, 3, 4, and 5. Am I correct? Here 0, 1, 2, 3, 4, 5. Now everyone tell me, what is 0 into 0?
0.
0.
Here
0, 0,
0.
everything becomes 0 because we are multiplying by 0.
And down also.
Okay, we can write down this also. Good. Now if I multiply by 1,
same number.
1, 2, 3, 4, 5.
2, 3, 4, 5. Should I write down here also? 2, 3, 4, 5. Am I correct? Now here we have interesting thing. What is 2 into 2?
4.
Okay, can I write down 4? Okay, what is 2 into 3?
0.
0.
It's 0. Very good. What is 4 into 2?
2.
It's 8, but 8 is congruent to 2. Very good. What is 5 into 2?
4.
4. Because 5 2s are 10, but 10 congruent to 4 mod 6. Very good. Here
0.
0. Very good.
3.
3,
0. 0.
0.
3.
Again 3. Very good. Here 4 2s are 8. 8 is congruent to 2.
2,
4 3s are 12. 12 is 0. 0, no? 6. 4
4,
4s are 16. So 12. 4. Very good.
4, 5 are 20.
20. 20. 6 2s are 8. So it becomes 2. 6 3s are 18. What about here? 10 is nothing but 4. 15 is nothing but 3. 20 is nothing but 2. 25 is nothing but 1. Am I correct?
Yes.
Yes, sir.
So this is what one. Tell me whether it is closed. It is closed, no beta.
Yes, sir.
Yeah. How it is closed?
Because if
Cause
we add any two numbers.
Yeah, we are doing no. So instead of adding, we have multiplication now. If you do any multiplication of any two numbers, so here what we are doing the same thing, no? Whatever the all possible multiplication we already done here. So we need to check whether in that element, that 6 by 6 matrix, whether in that element, in that 36 elements, whether we have any number which is not a part of Z6, whether you have any number like that.
No, sir.
No, every number is belongs to Z6. So whatever we have, do the product of this. So all numbers belongs to set itself. So first one is closed. Yes or no? Closed is done. Associative.
Yes, sir.
Why?
So multiply Yeah, multiplication.
Multiplication is
So it's also-
associative on Z, therefore it is associative on Z6. It is invariant property.
Yeah,
Associative. What about identity element? What is identity element here?
1.
One is
One.
the identity element. Can I write down 1? Everyone agree with that? 0 into 1. So I am getting 1. 1 into 1, I am getting, oh sorry, 0 into 1, I am getting 0. 1 into 1, I am getting
Yeah.
1. 1 into 2, 2. 1 into 3, 3. 1 into 4, 4. 1 into 5, 5. So identity. What about inverse? Fourth element. So I just write down A here, A inverse here. What is the inverse of 0? Check it out here. Whether I am getting identity somewhere.
No, sir.
So not exist. Not exist. Okay. So it is not a group. It is not a group. Well, let's check for the other elements, whether we have any other elements, so we can form something interesting. So what is the inverse of 1?
1.
1. Okay. What is inverse of 2?
Not, it doesn't exist.
Yes. So here, if I still make Z star, what is mean by Z star? Z star is nothing but all the elements other than 0. That is nothing but 1, 2, 3, 4, 5 only. Still, it is not a group.
Yeah.
Why? Because 2 does not have an inverse. Now you can multiply 2 to any number, which that number should be, you never get it is 1 in congruent modulo. If I 2 to multiply by 1, I am getting 2. If I am 2 to multiply here, that what I did. 2 multiply 0, I am getting 0, I am getting 2, I am getting 4, I am getting 0, I am getting 2, I am getting 4. Again, if I multiply by 6 is equivalent to multiply by 0. Because 6 2s you are getting 0 only. Yes or no? 6 2s are 12. 12 is nothing but 0. 7 2s are 14. That is nothing but 2. Like that only. So does not exist. What about 3? Whether 3
It
has the
does-
inverse?
Not exist.
3 also same. What about 4?
Same.
Doesn't exist.
Same. What about 5?
5.
Doesn't exist.
5.
5 has
No,
5.
5.
You know. 5 into 5, you are getting identity element 1.
Yes, sir.
So 5 5 is a 25. 25 mod 6 is nothing but 1. So 5 has the inverse. So whether this is a group?
No.
No. So what should you write down directly? You write down Z6 dot is not a group, is not a group, since which element does not have inverse? 0 comma
3, 4.
2 comma 3 comma 4
4.
does not have inverse. Everyone understand that? Z6 dot
Sir, how come it came with 5?
5 into 5. Tell me, what is 5 into 5?
25.
25. I'm taking under mod 6. What is 25 mod 6?
4.
4.
No, what is the
1.
remainder?
1.
One,
Acha,
no?
remainder 1. Yes. Acha,
Yes.
okay.
Got it?
Yes. That
Not
means
so 1.
we have to write down a remainder over here.
Yeah, that's why.
Okay.
That is what our operation is.
Okay.
That is
okay.
why the integer modulo n. That modulo is nothing but this one.
Okay.
Okay. So modulo n. So this is what the integer modulo n we always call this. Can I give you one more example? Now you can solve it. That example, tell me whether it is group or not. Okay. Instead of Z6, you can take Z7. Z7 dot. Z7 dot. Check whether Z7 dot is a group or not. What do you think? Whether it is group? What do you think? Z7. Can I write down here? Next question. Z7. Not 70, na? Z7. Together with each integer modulo 7 is a group. Okay. Tell me, what do you think about that? Whether it is group or not?
So the elements will be from 0 to 6, right?
Yeah, 0 to 6, correct.
No, sir, not a group.
Why?
Sir, because inverse does not exist.
Inverse does not exist. Okay. For which element you are talking about?
2.
Okay, let's check it out. I just form a table first. I form a table. Here I just write down 0, 1, 2, 3, 4, 5, 6, and 7. Here also 0, 1,
Only
2,
till 6. No?
3, 4. Okay, 5, 6. Yes, 6. That 7 is again 0. Correct. So 0 into 0, 0. Here I am getting 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 0. 0, 0. Correct. What I am getting here? Here also 0, 0. I just write down. What I'm getting here is 1, 2, 3, 4, 5, 6. And here also 1, 2, 3, 4, 5, 6. Okay. 2 to the 4. 3 to the
0.
no 6. No, 6 is not 0 here.
6, 6.
We have 7 here. Keep that thing in mind. That n. Got it?
3,
So
6,
6. Yes. 4 to the
1.
so we have inverse. The inverse of 2 is nothing but 4. 5 to the
3.
that is nothing but 10. 10 is congruent to 3 mod 7. And 6 to the 12.
5.
12 is nothing
Yeah.
but
So
5. What is next here? 3 to the 6. You can write down. 9. 9 you can write down as a 2.
2, 5, 1,
2, 5, 1.
4.
Correct. Next.
1.
1,
Yeah. 5.
5, 12. Correct. 16 is nothing but again 3.
2.
40. Yeah,
So
2, 2,
2.
2, 2, 2. Correct. 2. And here 20 we have 6.
6.
And 24 we have 3.
2.
Here again 5 to the 10. 10 is nothing but 3. 5 3 the 15 is nothing but 1. 5 4 the 20 is nothing but 6. 25 is nothing but
4.
3. 4. 4. 25 is nothing but 4. Correct. And
2.
30 is nothing but 2. Very good. Again here 6 to the 12.
5,
12 is nothing but 5.
4,
Here 4.
3, 2, 1.
3, 2, 1. Correct. Tell me whether it is group now.
Yes.
Oh, yes. Whether it is group?
No, sir.
So
Why?
close is finished. Associative is also satisfied.
Okay.
Identity.
What is
Okay.
identity? First one is closed.
Huh.
You need to write down why it is closed. That concept that for all A and B belongs to Z7. This
Yeah, yeah.
implies A into B also belongs to Z7. So it is closed. So you need to write down like that only. Yeah. It is closed under that binary operation we call as the associativity.
Yeah, it's a group, sir.
Everyone is agree it is a group?
Oh, no, so actually for 0 we don't get 1.
So
Yes,
0
yes.
does not have an inverse.
Sir,
So Z7 star will be a group, but
Ah.
Z7 won't be.
Z7 is not a group
0 does
under
not have
multiplication.
inverse.
Yes, 0 just because of that 0. If I remove that 0,
Yeah,
that
Z7 is.
0, then whether it is a group,
Yes, sir. Then it will be a group.
then it will form a group. So what is the difference between Z6 and Z7? Why this happens so? Because Z6 we have in a Z6 you don't have an inverse for 2, don't have an inverse for 3, don't have an inverse for 4. But here this is not the case. What is identity element? Tell me here. Identity element is 1. Okay. And the fourth one is inverse. So 0 does not have inverse. Okay. So the difference is what? Here that number
Sir, means for
n is prime.
associativity, it exists.
Associativity is also there.
Association associative always exists.
Always
Okay.
there.
Okay.
Identity element you can find out. So which element should I add? So you can see if I add 1 to 0, I'm getting 0, 1 to 1, I'm getting 1, 1 into 2, 2, 1 to 3, whatever that I'm getting same element. So this is nothing but what? A same, whatever the same element I'm getting as it is. So that 1 is nothing but your identity. Or you can draw this like that also, no problem. You are getting same after doing this binary operation on all that number. I'm getting same number. That's why that 1 is the inverse. 1 is the identity. But 0 does not have an inverse. Let's talk about the other elements inverse. So we will get the clear idea. So tell me, what is the inverse of 1?
1.
So I just write down A here and A inverse here. So 1 inverse of 1 is 1. What is inverse of 2, 3, 4, 5, 6? Inverse of 2?
4.
4 2 is 8, 8 is 1. Yes. Inverse of 3?
5.
5 is 15, 14. Yes, correct. Inverse of 4?
2,
2.
2 again. 5?
3,
And 3.
3.
3
And 6?
and 6.
3 and
6.
Inverse of 6 is 6?
6.
Because 6
Yes.
6 are 36. And if I talked about 7, so it
35.
becomes 35. So 1 is correct. Absolutely. But it is not a group. Still, just because of this. Because
0. Yeah.
all elements should have an inverse. So it is not a group. You can write down it is not a group. It is not a group. But if I write down Z, write down Rima. What about Z7 star comma dot? Whether it is a group.
Yeah, it's a group.
Yeah, it is a group. Okay, check it out. This is the homework.
So we
Sir,
Yes.
sir, can you tell me for this fourth 0 does not have inverse for 5 and 3? I didn't get it.
What? 0 does not have inverse.
Yes, so when A is 5, then first we need to do the multiplication. Then for 7, we need to just check the remainder, right?
Yes. Go ahead.
Okay, no, I just wanted to confirm that. How?
Okay. No. Here, what is binary operation? We have this
Product.
binary operation product. So we have identity element 1. You agree? Identity element
Yes.
is 1. Okay.
Yes.
So do you have any number? If you multiply 0 to that number, you will get identity.
Yes.
So do you have that number?
No.
No, which is not possible. See now about 4. Do you have any number? If you multiply that 4 to that number, you will get identity. Do you have a number? Listen carefully. Do you have a number to multiply with the 4? You will get and 1 as an answer in Z7. So that number is nothing but 2. Because what is 4 into 2?
8.
Whether 8 is congruent to 1 mod, what should write down 8 in Z7, which is 1.
1.
Okay. In another way, I will tell you how to write down Z6. So you need to write down Z7 now. So Z7 you can write down. Start with 0, 1, 2, 3, 4, 5, 6. You can write down 7, 8, 9, 10, 11, 12, here 13, here 14, here 15, here 16, here 17, here 18, here 19, here 20, here 21, dot. So when I talked about 17, the value of 17 in Z7 is 3.
Okay.
The value of 18 in Z7 is 4. The value of 22 in Z7 is 1.
Yes.
The value of 14 is 0. And similarly, we also have minus also. So
Okay.
you can write down -1, -2, -3, -4, -5, -6, -7. Like that only. So value of -4 is this. So you also represent your Z7 is like that. So we have 7 elements, no? So 1, 2, 3, 4, 5, 6, 7. So you can refine like that: -3, -2, -1, 0, 1, 2, 3, like that. So these are the 7, which is also another representation of Z6. Or someone is saying, so I just wanted to represent from 0 to 6. It's okay. I wanted to represent from 7 to 1, 2, 3, 4, 5, 6, 7 to 1 to 7. It's okay. Clean and clear. But it should contains only 7 elements.
Okay.
Now someone is saying, so whether -3 is congruent to, let's check it out. No, let's check it out. -3 is congruent to which number? Mod 7. What is that number should be? I just write down that number should be A. So what I want, -3 minus A is divisible by 7. What should be the value of that A? So it is divisible by 7. You will get a constant number. That should be 4. Because -3 minus 4 is -7. That K is the constant. So that's why here 4 is there. -3 is congruent to 4.
Yes.
Are you getting what I'm
Yes,
trying
sir.
to say?
Yes.
It is just a representation. Your actual main set is this only.
Which
And
one?
whatever the
This.
0, 1, 2, 3,
Okay,
4,
okay.
5, 6, and you just whatever another number you just relate to that number. Okay, this is related to this is related to this is related to this, like that only. Got it?
Yes, sir.
Anyone, any doubts here? Any doubts? Can I go further? We have lots of lots of to do with that things. Okay. Now we define a new group. Write down. I just defined that group, and you just show that whether it is group or not. Okay. So definition. Usually this group called as UN, that capital U, and it is called as multiplication modulo n, or UN. Write down UN be a set of all positive integer. Be a set of all positive integers. Set of all positive integers less than n. What is that n? That n is nothing but this. And relatively prime to n. What is mean by relatively prime? What is mean by relatively prime? Yes. What is mean by prime?
The number is indivisible by any number other than 1 or itself.
Okay. And what is mean by relatively prime? Relatively
The
prime is nothing but we have two numbers. You can take any two numbers. That two numbers are not divisible by each other. Just like 3 and 4. These are the relatively primes. Okay. 2 and any number is relatively prime. But 2 and 4 whether it is relatively prime? No, because 2 and 4 are divisible. We have factor common, that is 2. They don't have any common factor in that. Okay. So 7 and 19. Or 7 and 10. Whether 7 and 10 relatively prime? Yes.
No.
Why? Because 7 and 10 does not have any common factor. See, here 7 is prime, but 10 is not prime. But the combined 7 and 10 is relatively prime. Got it? Relatively prime. Okay.
Yes.
They don't share any common factor. That's it. Okay. So what they are talking about? Yes.
Means we need to choose a group when one is prime and the other is not prime.
No, not like that. Not like that. You can take 4, 4 and another number.
11.
No. I want 15. Tell me what is the common factor in between that? Whether 15 is prime,
No.
whether 4 is prime,
No.
both are non-prime, but these numbers are relatively prime. Why? They don't share any common factor.
Yes, they don't.
Got it?
Yes.
So what you are saying, it is not true. or sometimes it may happen 9, 1 is prime, okay, and 27. This is not prime, but this is prime. Whether this is relatively prime? Not.
Not
Because
because they
9 is
share
the
con.
9 is the common factor in between that.
Okay.
Got it?
Yes.
Clean and clear for relatively prime?
Yes, sir.
Okay. Now what they are saying? Such a set forms a group under multiplication. What is UN? So what is, tell me, what is U3? What is U3?
0, 1, 2.
0, 1, 2.
0, 1, 2. What next? What next? That's it. What here? What is that? Have you read the definition? What they are saying? It
Less
is what is any here?
3.
So what should be the number? How many numbers? Less than 3. So either it is 0, 1, 2, 3, and all positive. That's it. Got it?
But they are not relatively prime, na, sir?
Wow. Tell me which number is not relatively prime? 0 is not there. So we forget about 0. Okay, 0 we just dropped out because common factor is always 0. And we what I want somewhere I written non-zero. Okay, it's okay. What about 1? Whether 1 is relatively prime to 3?
Okay, related to 3. Yeah,
What is 2 is
but 2
relative?
is not.
Why? What is common factor between 2 and 3?
Okay, 1, 1. Right?
One is 1 and that number is always there. No, I'm talking about 3 and 5. What is common factor in between? 1 is always there. No, because 1 is the trivial.
Uh-huh.
No, 1. Just forget
But
about 1.
everything is common. Yeah.
Yes. Okay. Everyone
Mm.
understand that now? Other than 1, is there any common factor? Other than 1. So 1 is always there. 1 is always there. So not. So what about 3 and 2?
Yes, sir. 2 and
Okay.
3. Yeah.
Got it now? Everyone understand that? Tell me relatively prime to 10. Tell me what are the numbers?
From 0 to 9.
Tell me what are that numbers?
0, 1,
One.
2, 3, 4, 5, 6. Okay, there's no 0 now. So 1, 2, 3, 4, 5, 6, 7, 8, 9.
So can I write down here? 1, 2, next is 3. Whether 4 is there?
No, sir.
Yeah.
Oh, how? Yeah, how? No.
Why 2?
No, I'm just telling like the entire set of the
No,
numbers.
no. What I want, be a set of all positive integer less than n, and
Okay,
it is
then
relative
4.
to prime. So 2 is also not there.
3.
3 is there because there is no common factor between 10 and 3. What about 4?
5 is
7.
not there.
5 also not there. 7.
4 is not there. 5 is not there. 6,
6 is not there.
7. Okay.
Yes.
Yeah, it's
What about 8,
No.
not.
9?
No, sir.
Yes, sir.
Sir.
So what we have? 1, 3, 7, 9. Got it?
Hmm.
Okay. Now just
Sir.
check whether this is group or not under multiplication. Now
Okay.
check whether this is group or not under multiplication.
Sir,
I
how
just
come 9 will come?
what is the common factor between 9 and 10?
Yeah, got it, sir.
Okay, it's a very simple question. I got answer. Okay, tell me now, what is U12?
1, 7, 9, 11.
1. Whether 2 is there?
No.
No. 3 is not there. 4 not there. 5 is there. No, beta.
5.
6 is not there. 7 is there.
7.
8 is not there. 9 is there. Not there.
Not there.
10 is not there. And 11.
11.
1, 5, 7, 11. Got it?
Yes, sir.
Now they are saying this is a group under multiplication. You need to check it out. That is homework task. Okay. And I request everyone, please put your attendance in the chat box. So homework. You can check above 3 elements. For above 3. Check. What? U3, U10 and U12 is group or not?
Sir,
Everyone?
can you scroll bit down?
Yeah. Do you understand how to solve this one? It hardly take 10 minutes. Because it has very simple elements. 1, 2, 1, 3, 7, 5, like that. Okay. They are saying UN forms a group under usual multiplication modulo n. Multiplication modulo n. We need to speed up now.